Hi everyone, I'm glad to be here. Today I'm going to talk about zero MMC and LMC. If we have time, I'm going to talk about different types of fields. Let's talk about zero MMC. Please see this figure at the top. We have the hole. The diameter of this hole should be between 10.5 and 10.9. We have the value of MMC equal to 0.3. When we have the modifier, we are going to calculate the virtual condition or virtual boundary. For the hole, we should have the smallest hole 10.5 minus 0.3, we have 10.2. And then for different value of the hole diameter, we are going to calculate what can be the possibility for the tolerance regarding to the center of the hole. It is 0.3, for example, for 10.5. Here, for this case, when MMC equal to 0.3, we have a difficulty, we have a problem. If the whole diameter is 10.3, it is not acceptable diameter because at the beginning, the diameter of the hole should be in this interval, 10.5 and 10.9. But by having diameter of the hole 10.3, we are not going to satisfy this condition and then it doesn't work. We need to reject this component. However, we can see if the diameter of hole at the beginning is 10.5 and we have these tolerances, it's going to cover the diameter of hole as 10.3. In order to solve this difficulty, we are going to change the value of the MMC to 0 and we are going to make bigger interval for the whole diameter. As we can see here in the second figure at the bottom, the whole diameter should be in this interval, 10.2 and 10.9, and value of MMC equal to 0. What does it mean? To have zero tolerance, it doesn't make that much sense. But by using the concept of the MMC, we can have second part of this table. If MMC equal to 0, the smallest whole diameter can be 10.2, and for different whole diameter, we are going to calculate the tolerance zone. In this situation, as we can see, if the whole diameter is 10.3, it is acceptable. It is in this interval, and it doesn't go through the virtual boundary or condition. And this green area is the same as here. And by having 0 mmc and increase the interval of the diameter of the hole, we are going to cover also 10.2, 10.3, and 10.4. That is a concept of 0 mmc. In a case when the value of the mmc is big enough in comparison with the interval of the, let's say here, hole diameter, it is good to have a 0 mmc. Yeah, let's go to next page and talk about least material condition, LMC. The symbol for LMC is L inside the circle. The concept is exactly the same as MMC but in opposite direction. For example, here we have a shaft with a diameter of 0.5. The tolerance zone is this value. We have 0.01 for LMC. LMC means least material exists on the component. If we have the pin, we should have the smallest pin. And here, for this example, top right, we can see by having this value 0.5 minus 0.008, we are going to have least material condition for pin. The same concept is going to use for the hole. In this example, as we can see here, bottom right, in this figure, by having diameter of the hole equal to 0.526, it should be in this interval. In order to have least material on this hole, we should have the biggest hole diameter, and then we are going to calculate the summation of this diameter and the maximum value of the allowable tolerance. For that, we can calculate least material condition. Let's talk about this example. The left-hand side, we have the perpendicularity symbol here, and the diameter of the hole should be between 12 and 13. And the least material condition, we have it here. The value of that is equal to 0.1. We need to calculate the virtual condition for that, and then we should have the biggest hole to have least material on this component. Sorry. And then here, when we have a biggest hole, we need to add this value on that, and we are going to make this, let's say, virtual boundary or virtual condition for the hole, and the other hole should be in this virtual condition based on the perpendicularity. Another example is here. Again, we have the hole diameter between 12 and 13, and the value of the LMC is 0.2 for the positioning. And for the center of the hole, we are going to make, first we are going to make this virtual condition. We should have the biggest hole, 13 plus 0.2, and then the positioning of the center of the hole can change in this interval 0.2, and it's going to change based on the hole diameter. It is dynamic tolerance, the same as always. We have LMC or MMC condition. It means we are going to have a dynamic tolerance. Let's talk about this example. Here easily we can see in the table what I mean with dynamic tolerance. In this example, we have diameter of the hole equal to 12. It should be, the tolerance zone is positive 0.2 and minus 0.1 for different hole diameter between 11.9 and 12.2. If we don't have this symbol, least material condition, the tolerance zones would be 0.2 for all different hole diameter. When we have a least material condition L, we are going to calculate what is the virtual condition. We should have the least material exists on component. It means we are going to have a largest hole, and for this one 12.2 plus 0.2, we have 12.4. And for different hole diameter, we are going to calculate what is the value of the tolerance zone. As you can see, when the hole is the smaller, the center of the hole can move more. It means we are going to have a dynamic tolerance. And here the topic about LMC and MMC is going to finish. In this page, let's recap MMC and LMC. So far, we have implemented this symbol MMC or LMC in second box. For MMC, when we are going to assemble two components, for example, here we can see bolt is going through the holes. We have two components. In order to avoid any interference between two pieces, we are going to implement MMC. In a condition when we need to have a minimum thickness between two holes, or between the hole and edge, we are going to consider least material condition to have a minimum thickness for this component, for example, as you can see here. Later on, when I have explained this datum plane or reference plane, I'm going to implement this MMC condition or least material condition for that. And for now, I would like to close this session. I hope you enjoy it, and see you next time. Have a nice time.